1. The birth of a number. For thousands of years, numbers have been regarded as abstract symbols, simple marks on paper, tools for counting, for measuring, for describing the world around us. But what if numbers are much more than that? What if every number possesses a hidden geometric structure waiting to be discovered? Consider the simplest possible number. 1. At first glance, it seems almost trivial, yet even the number 1 can be written in a remarkable way. 1 squared plus 0 squared plus 0 squared plus 0 squared. Not merely an equation, but a set of 4 coordinates. A single point in a 4-dimensional space, a space beyond ordinary experience. A space where arithmetic becomes geometry, where numbers become objects, where relationships become shapes. This simple point is the first step into an entirely new mathematical landscape, a landscape populated by extraordinary symmetries, hidden lattices, and beautiful geometric structures that have remained largely unexplored. Everything that follows begins here, with a single number, a single point, and a question. What does a number really look like? This is only the beginning. Two. The integer shell. We began with a single number, a single point. But one point alone tells us very little. The true beauty begins to emerge when we consider every possible representation of the same number. Take the number 5. It can be written as the sum of 4 squares in more than one way. Each representation defines a different point in 4-dimensional space. Together, these points form a remarkable geometric object. We call it an integer shell. It is not drawn by hand. It is not invented. It emerges naturally from arithmetic itself. Every point on the shell satisfies the same simple equation. The coordinates may change, but the number remains the same. As we move from point to point, we are not changing the number. We are revealing its hidden geometric structure. For small numbers, the shell contains only a few points. For larger numbers, the shell grows richer and more intricate. Patterns begin to appear. Symmetries become visible. Order emerges from what first seemed like a collection of unrelated solutions. This is the first glimpse of a new way of seeing numbers, not as isolated values, but as complete geometric worlds. And this is only the beginning. Every integer has its own shell, each one waiting to be explored. Three. Hidden symmetry. In the previous scene, we discovered that every integer possesses its own geometric shell, a collection of points, each representing a different way of writing the same number as the sum of 4 squares. At first glance, these points may appear to be scattered at random, but mathematics rarely rewards first impressions. Rotate the shell. Look at it from another direction, then another. Patterns begin to emerge. Points align. Shapes repeat. Entire regions mirror one another with astonishing precision. This is not coincidence. It is symmetry, a hidden order woven into the arithmetic itself. The same number can be represented in many different ways. Yet together, those representations form a single, coherent geometric object. The shell behaves almost like a crystal, not a crystal built from atoms, but one built entirely from numbers. As the integers grow larger, their shells become richer and more intricate. New patterns appear. Old patterns return in unexpected places. The geometry becomes increasingly beautiful. What began as a simple equation has become a landscape filled with structure. And symmetry is our guide. Because hidden within these shells lies one of the most remarkable objects in four-dimensional geometry, a shape whose elegance has fascinated mathematicians for more than a century. The journey toward that shape begins now. Four. A perfect four-dimensional shape. Throughout our journey, a pattern has been quietly revealing itself. The shells are not random. Their symmetries are not accidents. Again and again, the same geometric relationships appear, almost as though the numbers are trying to tell us something. As we continue exploring these hidden structures, one remarkable shape begins to emerge. Perfectly balanced, perfectly symmetrical. Unlike anything that exists in ordinary three-dimensional space, a shape that belongs entirely to four dimensions. It is composed of 24 identical cells, each one an octahedron. Together, they form one of the 6 regular polytopies of four-dimensional geometry, known simply as the 24 cell. It has no true three-dimensional equivalent. No ordinary object can fully capture its beauty. Yet its symmetry reaches into every corner of four-dimensional space, its vertices, its edges, its faces, its cells. Everything exists in perfect harmony. For more than a century, mathematicians have admired this extraordinary object for its elegance. But here, it appears for a different reason. Not because we constructed it, not because we searched for it. It emerged naturally. From arithmetic, from nothing more than expressing numbers as the sum of 4 squares. The deeper we look into numbers, the more geometry we discover. And the deeper we explore geometry, the more the numbers begin to reveal their hidden order. The journey has only just begun. Five. The hidden lattice. The 24 cell is extraordinary, but an even greater surprise is waiting. The 24 vertices we have been admiring are not isolated points. They belong to something much larger. Imagine extending this structure in every direction, not just across ordinary space, but throughout 4 dimensions, each point surrounded by identical neighbors, each neighborhood repeating the same perfect pattern, an infinite geometric network. A lattice. Every point occupies its precise position. No point is special. No point is unique. The entire structure repeats endlessly with perfect regularity. Within this infinite lattice, the 24 cell appears naturally. It is simply the nearest neighborhood around a single point. The first layer of an immense four-dimensional crystal. This remarkable lattice is known as the Hurwitz lattice. It is built from special numbers called Hurwitz integers. At first, they may seem like ordinary coordinates, but they possess an extraordinary property. They can be added, they can be multiplied, and every operation preserves the elegant structure of the lattice. Arithmetic and geometry become one. What began as simple sums of 4 squares has revealed an infinite mathematical universe. Every point, every shell, every symmetry, every 24 cell. They are all part of the same hidden design, and we have only explored its outermost layer. Beyond this lattice, an even deeper structure is waiting to be discovered.